So today is all about polynomial operations, and we are just going to name polynomials. You guys did that in Math 2. Then we are going to add, subtract, and multiply. We're going to keep division of polynomials until later on, Unit 9 and 10. We're going to divide those in a bit more detail than what we did in Math 2. So Math 3, starting off with our polynomial types that we have. And you guys probably remember a lot of these names, don't you? Let's hope so. So first off, you'll hear me say degree a lot. Degree is the highest power on the variable, and the names on the left side refer to the degree. So when you see the word constant, I'm just going to write examples by these. When you see the word constant, it's just a number with no variable. So an example of that could be like the number 3. Linear. When you think about linear, what do you think about? A 1, a power of 1. Y equals mx plus b is another thing that comes in mind. So an example of that is like 2x plus 1. You can have additional things added and subtracted. Just the highest power has to be a 1. What about quadratic? When you think about quadratic, what power do you think about? 2, it's actually 2. A lot of us think 4 because quad 4, but it's actually a 2. So it would be like negative x squared plus 2x minus 1. That would be a good example of a quadratic because it has that x squared power. Cubic, third. So like 3x to the third minus 4x. It doesn't have to have all the other terms. You're just looking at the highest power. What about quartic? That's the 4. So x to the 4th minus 1. And what about quintic? Good. So 2x to the 5th plus 3x squared. And there are some examples. And I just made up extra variables to go along with them because it doesn't matter what else is there. You're just looking for that highest power that you have. So constant doesn't have an x at all. And then the other powers have a power of 1, 2, 3, 4, 5 to go along with your linear, quadratic, cubic, quartic, quintic. After that, anything beyond a power of 5, we say it's the nth degree. So if it has a power of, let's say, 8, we'd say it's the 8th degree polynomial. So whatever after 5, the nth degree. Now, we also name these things based on how many terms that they have. So over here is your degree. That's the highest power. And over here is names for how many terms that you have. So when you see the name monomial, what do you think monomial means? 1 term. So like 3x. Binomial, 2 terms. Trinomial. And polynomial. Good. And really, polynomial is a name for all of the types that we have. I always like to use this example, like you are all students, right? At the early college, but some of you are freshmen, sophomores, juniors, seniors, and that's how we denote the different ones. So all of these things that I've just written on the board, they're all polynomials, but we specify them a little bit closer, talking about monomials, binomials, trinomials. We are going to factor a lot tomorrow. We might do a little bit today, but we're going to factor a lot tomorrow, and with that factoring, we are going to use these terms because we are not going to factor just quadratics like we did in Math 2, but we're going to factor some cubics, quartics, quintics, and some higher power ones as well. So lots of different things that we're going to do. But today what we're going to do is write things in standard form and name them. So standard form is after you simplify and you order your polynomial from the highest power down to the lowest power. You guys probably remember doing that in math too. So let's do some examples. So write down those instructions and then you can copy down these problems. Save maybe a line or two between each one. We're going to write it in standard form and name them. So we want to write these in standard form, then classify them based on their degree and number of terms. So using two of those names from the first slide. So what do we do with this first problem? Combine like terms, we get 10x plus 5. All right, let's name it. It is a binomial. Good, because it has two terms. Good, and linear. It kind of looks like mx plus b, doesn't it? So that would be a linear binomial. That x has a power of 1, so it's linear. There are two parts, so it's binomial. All right, let's look at problem 2. 2m squared minus 3 plus 7m. Now, do we have any like terms to put together? No, but is it in order? No, so let's put it in order. Good. And remember, keep the same sign that's with the number. So the 7m and the minus 3 switch, but we keep the negative with the 3. So this has the highest power of, so it is a, and how many terms does it have? So it's a, very good, quadratic trinomial. Now, for your notes, if you shorthand them, that's okay. But for your homework, tests, quizzes, go ahead and write out the whole word. Okay? So just get in that habit of writing out the whole word. Make sure that you can spell it correctly and all that kind of stuff. All right, problem 3. Negative 4p plus 3p plus 2p squared. We got to combine like terms and put it in order, right? What's the highest power? 2p squared. And then we combine these two together and we get negative 1p. And then how would we name this one? Quadratic binomial. Good. It's got the power of 2, which makes it a quadratic. Got two terms, which makes it a binomial. Ta-da. Question 4. Negative x to the 5th. Quintic monomial. We don't have anything to combine or anything like that. If you see this on your homework where it's just one term, on your homework, rewrite the term so that way I know that is the final answer in standard form, and then name it. So quintic because the power of 5, monomial because there's only one term there. Very good. All right, what about question 5? 6x to the 3rd minus x to the 3rd. Combine them, we get what? 5x to the 3rd. Did we change our exponent? No, we only add or subtract the coefficients, which are the numbers in front. So remember, do not change exponents when writing in standard form. We're just combining like terms, adding those together, and we name it. It's a, very good. Is it too easy so far? I mean, just a little bit. Of course, it's going to get harder. We can't just stay like this all year. It'd be boring. All right, so let's do some simplifying. Oh, you're like, all right. Let me make this a little bit bigger for you guys so y'all can kind of see the problems a little better. Is that okay? All right. Just write down problem number 6 so far. Just got some more things in there. Now, here we have a polynomial and another polynomial. And what's between them? An addition sign. So what are we going to do? We just add up like terms. That's all we got to do. They're just written in parentheses, denoting one polynomial from another polynomial. So let's just add up things that are alike. So things that are alike have the same variable with the exponent. That's right. So this 6x to the third could add with and make. Good. Then we have a 3x squared and a. They cancel out. Okay. Then I have an x term. Do I have any other x terms? No. So I just bring that one down. And then last I have a plus 5 and a. 5 minus 2 is 3. Now let's name it. It's a. Very good. Now, I typically do this. I like underline and put squiggle marks under and circle and box things that are alike to find them. You guys can also do it another way. I know that we did it this way in Math 2, where we took that second equation and we wrote it underneath the first equation and made it like a column addition. And so if you want to do it like that and add them up, you are more than welcome to do it that way. It's whichever way that you like the best. Okay, let's write down our second problem here. Can y'all see the exponents and everything okay, or do I need to make it bigger? It's good? Okay. Now, this one is a little bit different because what's in the middle? It's a minus. So what do we have to do if there's a minus? That's right. If you ever see a negative, you have to distribute that to all the terms. So don't go through and just start minusing them. Go ahead and distribute. And if you like to write it all in a full line, you can do that. Typically in Math 3, I start writing everything kind of just more linear straight this way instead of up and down. So we have a minus 3x, but then this next term is going to become positive 2x squared, and then the last term, positive 1. Okay, so distribute that to all the terms and then add them up together. Is this an easy problem? Do you know how people make mistakes on this? They don't distribute the negative, and then they get like 2/3 of the problem wrong because they ended up doing it to the first one, but not the other two terms. So write it all out. Take your time. Don't just go through and say, oh, I can do this in my head, because you will probably make a mistake at some point, and that's an easy point that you don't need to lose. All right, so let's add up our like terms. So I have a 2x squared and a 2x squared, or 12, sorry. That makes. And then I have a 7x and a 3x. So plus 4x, because one was positive, one's negative. And then a minus 1 and a plus 1 cancels out. If you like to use colored pencils here or highlighters, that's a good thing too. You can underline them in different colors. All right, and name it. It's a perfect quadratic binomial. All right, so let's do another subtraction. We're mainly just looking for things that are alike, and we're putting them together. You also want to make sure that all of your answers are written in standard form. So you might see me or hear me like look for that highest power first and then try to combine that together with another term. So what's between the parentheses? A negative. So we only distribute what's right there in front of that parenthesis. So let's distribute that negative through. So I have 5x to the 4th. Minus x squared plus 3, and that negative is going to change the signs of everything. So negative 3x to the 3rd minus 2x squared plus x minus 3. Get in that habit of writing it all out. Distribute that negative. It's pretty simple, but you don't want to make a mistake. Now, if we're writing this in standard form, we look for that highest power first. What's the highest power? 5x to the 4th. Do I have any x to the 4ths? Nope. Next would be an x to the 3rd. Do I have an x to the 3rd? Yep, this minus 3x to the 3rd. Do I have anything else? Nope. I've seen people do this as well, and if you want to do this, you can. They go through and like mark out the ones that they've used so that way they know they're gone. I'm marking it out with a highlighter so that way we can still see it. So next we would have an x squared and x squared. So I see a minus x squared and a minus 2x squared. That becomes negative 3x squared. And then next would be plus x. There's no other x term there. So plus x. And then last, the 3's cancel out. So how would we name this one? That's right, quartic polynomial. Some books tell you to say the term, like some books will say, this is a quartic 4th term polynomial. I don't think you need that. Just call it a polynomial. All right, our next one is slightly different because what's between the two polynomials? What's between? It's a multiplication. So there is nothing there, so it's an imaginary multiply. Now, can I just multiply one thing? What am I going to have to do here? Distribute everything in the first to everything in the second. This x distributes, then the 2 will distribute. So some people call it FOIL, first, outer, inner, last. You remember this? So what's x times x? Good. When you multiply, remember you add the exponents. What's x times negative 5? Now distribute the 2. 2 times x. And then 2 times negative 5. And then normally if you have a binomial and a binomial, you have some like terms there in the middle. So our middle term will change to negative 3x. So this is a good quadratic trinomial. All right, we got a few more to do. They just pop out of nowhere. Number 10 is pretty much the same. Let's just go through and multiply those again. So we're going to distribute the x and then distribute the negative 4. So what's x times x? X times negative 1. Negative 4 times x. And negative 4 times negative 1. Good. Combined up those like terms in the middle. So we have x squared. And we would name it. Good. There are some helpful hints that can help you multiply these really quickly. And it's kind of like when we factor, and we're going to talk about them again tomorrow. But if you see these little binomials that you're multiplying, it's x plus a number, x minus a number, you can get to this problem real simply by adding these two parts together. What's negative 4 minus 1? Negative 5. And then multiplying together. What's negative 4 times negative 1? Positive 4. So if you add the numbers, you get the middle term. If you multiply the numbers, you get the last term. So that's a shortcut for you. Same with here. What's positive 2 times negative 5? Negative 10. And what's positive 2 plus negative 5? Negative 3. So if you multiply them, you get the last. If you add them, you get the middle. That might sound familiar when we do our factoring. So if you can do the shortcut, go right ahead. You don't have to show all the pieces if you want to shortcut it out. It might be easier when you get to pre-calc to do it the shortcut way, but you don't have to. Okay, let's look at our next problem. We have 3 parentheses that we're multiplying. Now think about when you multiply 3 different numbers together. What if I told you to multiply 2 times 3 times 5? What would you do? Multiply the first 2 and then multiply it by the third, right? So you would do 2 times 3 first, which would make 6, and then multiply that by 5, which would make 30. Would you multiply 2 times 3 and 2 times 5 and then multiply those together? No. So you do the same thing here. Ignore the third one for right now and just distribute and multiply the first 2 together. Now, if you want to use that shortcut, you go ahead and use the shortcut. If not, I'm going to multiply them out separately anyway. So distribute the x. X squared minus 3x. Then distribute the 2. So it's plus 2x minus 6. Combined up those like terms, we get x squared minus x minus 6. And if you do the shortcut, 2 minus 3 makes negative 1. 2 times negative 3 makes negative 6. Now, once you have multiplied all that, put parentheses around it and bring down the third parenthesis. So you multiply the first 2 together and get that answer. Now you multiply that answer by the third one. Now, to multiply these, you distribute until you can't distribute no more. Okay? So I'm going to take my x squared and I multiply it first. So what is x squared times x? X to the third if there's a power times a power. So I add, what's x squared times negative 3? Negative 3x squared. Then take your negative x and you're going to multiply it. You're going to distribute it. So what's negative x times x? What's negative x times negative 3? Now we're going to distribute one more time. Now we have this negative 6 that's going to distribute. So everything in the front has to multiply everything in the second. So what's negative 6 times x? And negative 6 times negative 3? Good. Now combined up those like terms. So I see an x to the third at the beginning, so I write that down. What I like about multiplying in this way, your like terms are right there together. So what's negative 3x squared minus x squared? Then we have a 3x minus 6x. And then we have our plus 18. So you distribute till you can't distribute no more. And then we name it. This is a good cubic polynomial. And we have one last one of these multiplines to do. I don't know what's on the next few pages. Now, this one has an x, then an x plus 1 squared. Can I distribute the squared? No. Remember how when we sung the song, if there's a product to a power you can share? Well, product meant what? What does product mean? Multiplication. So a product means if things are multiplied together, then you can share the exponent. So you cannot share over addition. So you might want to write this down. Can't share exponent over addition or subtraction. I should put add or subtraction. So you can't share that with all the other terms. But what do we do if something is squared? Write it twice. Very good. Now, the only thing that you're writing twice is that parenthesis. So there's still an x on the outside, and then you have x plus 1, x plus 1. Now, how do we multiply these? Distribute the x to the first parenthesis. I would also do that. Ignore the third one. Remember, you're just working with the first two. So that becomes x squared plus x. And then bring down that x plus 1. Now, distribute some more. So what's x squared times x? And then x squared times 1. And then take the next parenthesis and distribute it. So then we're multiplying by x. So we end up with. Good. And now let's combine up those like terms. I'll keep my x to the third there at the beginning. These two, put them together, we make 2x squared because we're adding the numbers in front. And then plus 1. So if something is squared, write it twice. Did I mess up? Yeah, there it is. Look, that's an x. My bad. Yeah, you're right. It would be a 1x, not just a 1. I got excited. I just kept going too fast. All right, let's name it. This would be a good cubic trinomial. So we have added, we have subtracted, we have multiplied. So when you multiply, distribute, combined up those like terms. Don't forget if you have a subtraction, distribute the negative, addition, just add up your like terms. Let's see what's next. A word problem. You don't have to write all this down. Let's just read it together. Don't write it down. Let's just read it together first. As you notice in Math 3, there are a lot of word problems, and this one came out of a 97-page document that they sent us math teachers from the state of North Carolina with examples that go along with the standards that they wrote, which are sometimes confusing. So I pulled this, though, from that example. So don't freak out when you see words. Let's read it. Last year, Army engineers modeled the function of a bullet fired by a U.S. soldier from a certain weapon. The function f of x modeled the path of the bullet. This year, the soldiers were supplied with more powerful guns that changed the path of the bullet from higher ground by adding the function g of x. What function models the path of the new bullet? So what did they do? They added the functions together, right? So what do we need to do? Just add them. Yeah, so what I want you guys to do is write down f of x, write down g of x, and then we're going to add them together. Y'all were so scared. Next time I'm really going to scare y'all. I'm going to put like one of those things on the screen that like, it looks like a pretty little meadow, and then all of a sudden a scary, like, ghost person, zombie jumps out at you. Now that's scary. Now you may see it written a slightly different way, like you might see it written as like f of x plus g of x, because that's basically what we're doing. But we're taking our two equations, and if you're looking at a textbook, they're going to put them in parentheses and add them together. But do you have to put them in parentheses to add things together? No, you're just going to add the things that are alike. So go ahead and add those up and simplify that equation. Some of you already have. So what's the answer? Good. Negative 16x squared plus 500x plus 24. Now, it's a word problem, so we don't have to name this. It just said what function models the path of the new bullet. It was multiple choice, and I took off the multiple choice options. But that would be our final answer. Just add those like terms together, because the keyword said that it added the functions together. So that's all we do is add them up. All right, let's see what's on this last slide. Oh, I think it might actually be your homework, because I added a slide to it, and it's not changing. And it is your homework. Your homework is on Canvas, so go on there, log in, and do that homework assignment. If you all finish up, we might go ahead and jump into some factoring at the end of class.